Welcome to Solving Exponential Equations 5.5. I think you guys will really like these. If you review back to solving linear functions, we've done that in class just a little bit. Let me just go over one like 3x plus 2 equals 17. You draw the line, write your PIMDAs, circle your creepy dude and keep your spotlight on him. What is being added or subtracted to him on this side of the teeter-totter? It would be a plus 2. So we mark out add. That means we need to subtract to get rid of it. Subtract from both sides. You have to keep that teeter-totter level. So what you do to one side, you do the other. So we have that wipes out. We get 3x equals 15. Now, coming up your PIMDAs ladder, we've added and subtracted, or we've not added. We saw that it was a plus 2, so we subtracted. Now we see it's a times 3, so divide by 3. Mark that out. And we get x equals 5. Then you could plug it in and check it. Same kind of approach here. We want to make sure and draw our line, and we want to get this x isolated. So the first thing we look at is away from the x, we have a times by 5 halves. In order to get rid of that times by 5 halves, we would say divide by 5 halves, but we know when you're dividing by a fraction, it is skip, flip, and multiply. So to just shorten our work here, we just go ahead and show that it's skipped, flipped, and multiplied. Put that over 1. Skip, flip, and multiply. So what you do on one side, you do on the other of this line of the equals. So these cancel. 5 will go into 80 16 times. Now we have 2 to what power equals 16 times 2 is 32. Well, that means we need to find how many 2's multiply to equal 32. You need to start breaking it down. You might say 8 and 4. You could break down in a lot of ways there. 8 breaks down to 4 and 2. Circle that 2. 4 breaks down to 2 and 2. Circle that. And this 4 needs to break down to 2 and 2. How many 2's multiply to equal 32? 1, 2, 3, 4, 5. So we can rewrite that equation now as 2 to the x equals 2 to the 5. When your bases are the same, you can ignore them and you've found what your x is equal to. Plug it in and make sure that it works back in the original equation. So now we have something like this. And you go, yeah, well, when I break 9 down, I get 3 and 3. So what shall we do? The easiest thing to do on this kind of a problem is to separate them into separate lines and graph them as a system. So we would go f of x equals 2 to the x, and f of x equals 9. Now I just put away my graphing board, so you're going to have to forgive me. It'll be sketched in your notes anyway. F of x equals 9, that's like y equals 9. When you have one variable, you just cut through that axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That is y to the 9th. Now, f of x, 2 to the x, if you need to make a t-chart, do so. When x is negative 1, that would be 2 to the negative 1. That would be 1/2. And x is 0. 2 to the 0th is 1. Remember, this is your b value. Your a value is 1 out here. 2 to the 1st would be 2. 2 squared would be 4. That's enough to plot your points. Just plot them just like this. Okay, so at negative 1, we can come up to 1/2. At 0, come to 1. At 1, come up to 2. At 2, come up to 4. to keep extending. So at 3, it's 8, and at 4, it's 16. So I'd come over to 3 and show it right here at 8, and go up to 4 and show it at 16. It crosses somewhere between this 3 and 4 at the 9, because 3 is right there and 4 is up there. So this is between 3 and 4. That's the solution. Now, I would suggest that you put that in a graphing calculator and find the exact solution. Make sure that you've done that in class. Make sure you know how, because you'll need to for the final exam. So make sure you know how from me. I'd like you to sketch it as well. Okay, now we've got a word problem here. 175 deer in the park. Population increases at 12% per year. When will the population reach 300? Well, hopefully this population increasing reminds you of a few days ago when we did increasing. So I hope you're saying, well, we start at 175 and we multiply by a growth factor of 100% plus 12%, because of the increase, would be 112%. Switch that back to a decimal, would be 1.12 to the x. And we're wanting to know when that will reach 300. This one, you definitely want to put into the calculator. When you get the calculator, go to 175, parenthesis, 1.12, raised, use that button, and there is an alpha button. And the alpha button is either green or yellow, and then look for the little marking above the buttons in green or yellow will have an X. Not sure which button it'll be on the calculator that you're using. And I want you to put that into Y1 into your graphing table, and then do your other graphing table, Y2, as 300, and then let's go to the graph and see where they intersect. Again, that's one to make sure you know how to do on the graphing calculator. It'll be very similar to the other one. Thank you.